Hello, virtual learners. Today we are completing Math Lesson 7-2, and if you're in your math journal, it's page 237. If you're following along on GoFormative, then you should have this page in front of you. And today we're going to talk about renaming mixed numbers and fractions. When they say rename, they're really just telling you to think of another way to show or say the same thing. So today we're going to talk about two different things. We're going to talk about visualizing or using these fraction type pieces, which I know you don't have in front of you, so you can draw them out to help you, or using the MAD strategy, M-A-D, and I'm going to show you both ways, okay? So if you look at this box, they're telling us if one whole circle is worth 1, then what would 3 whole circles, and then we have some fraction pieces, be worth? So a mixed number name is 3 and 5/6. Here are the three holes. And then I have 1, 2, 3, 4, 5. If I had another piece here, this would be the 6. So 5/6. 3 and 5/6 means 3 whole pieces plus 5/6 of another circle. So another way to think of that is to take this and draw it like this as sixths. And if you counted up each of the sixths, you would get 23 sixths. So we can use this strategy of trading these whole pieces for fraction pieces to solve these problems. And we can use the MAD strategy, which if you have forgotten what that means, this is multiply, this is add, and this is keep the denominator. And I'll show you both ways. Okay? So let's look at number 1. Write the following mixed numbers as fractions. You may use your fraction circle pieces so we can draw them, or a fraction number line poster to help you, or we can use the MAD strategy too. So 1 and 2/3. If I were to draw this in fraction pieces, I would have 1 whole circle, okay, and then 2/3 of another circle. So here would be my circle, and I would divide it into thirds. So that's like saying I have 1 whole circle and then 2/3 of another. If I were to also divide this into thirds, just like they did up here, and I counted all of my thirds, I would have 1/3, 2/3, 3/3, 4/3, 5/3. And I wouldn't count this extra piece because it's not shaded, okay? If I were to do the MAD strategy with this, you would, and I'll write it a little bit bigger so you can see it here. You would multiply here and add here. So 1 times 3 is 3, plus 2 more, 4, 5. And then I keep the denominator. So I have 5/3 both ways. So I can show it with my pieces, trading whole circles for fraction pieces, or I can use the MAD strategy. So let's look at number 2. 2 and 3/5. So 2 whole circles. And then, and actually I'm going to change this to make it rectangles because that'll be easier to divide into fifths. So here is a rectangle and here is a rectangle. That's my 2 holes. And then we'll do 3/5 of another one. So 1, 2, 3, 4, 5. And I have 1, 2, 3/5 of that. I'm still going to divide these into fifths, just like they did up here. They took these 3 holes and they divided them into sixths. Going to do the same thing here, but in fifths because that's my denominator. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it was 2 and 3/5. So I'm going to shade this whole thing. And then only 3/5 of this one. Then I count all of my fifths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13/5 is a way to rename this mixed number, Or I could do the math strategy, 2 3/5, multiply, add. 2 and 5 is 10, plus 3 more is 13, and I keep the denominator. I get the same answer both times. Okay? Let's look at this one. 5 3/4. Okay, so 1, 2, 3, 4, 5, and they're in fourths. And I'm going to shade the whole circle because I have 5 whole circles. And then for my last one, I'm just going to shade 3 out of the 4 pieces. Then I would count all of the fourths that I have shaded. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. This was 23 fourths. And I can do the math strategy as well. 5 3/4. 4 times 5 is 20. 20 plus 3 more is 23. And I keep the denominator. So 23/4. They are the same. Using the math strategy or using these fraction pieces, it's just a way to check your work. So if you're using this one, you can use the math strategy to check and make sure you have the right answer. If you're using the math strategy, you can draw it out to check to make sure that you have the right answer. If you're doing both strategies correctly, you should get the same answer each time. We'll do number 4 together, and then I'll let you try number 5 and 6 on your own. So again, these are fifths, not very easy to divide with circles, so I'm going to draw rectangles, 6 of them. So 1, 2, 3, 4, 5, 6, and they're divided into fifths. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So these are my 6 whole rectangles that have been divided into fifths, and then I need 1/5 of another one. 1, 2, 3, 1, 2, 3, 4, 5, but I'm only going to shade one piece. These are all shaded. So I know that 6 times 5 is 30 little fifths, plus 1 more is 31 fifths. Or I can do the math strategy. 5 times 6 is 30. 30 plus 1 is 31. I would get 31 fifths. Okay, so I want you to try number 5 and number 6 on your own and to put those answers into your Go formative. Okay. Down here it says write the following fractions as whole numbers or mixed numbers with the greatest whole number possible. You can again use fraction circle pieces to help you. So 7/3. They want me to reduce this to make it a mixed number. When you have an improper fraction like this, they want you to reduce it. So you're asking yourself, it kind of becomes a division problem. 7 divided by 3. How many times does 3 go into 7? Well, 2 times. I know that 2 times 3 is 6. I subtract. That leaves me with 1 left over. Now we don't say it's 2 remainder 1. When we're dealing with fractions, we write these remainders as fractions. So it's 2 1/3. Okay, so this is 2 1/3. For number 8, 2 over 1, I know that any whole number over a 1 is just that whole number. So 2 over 1 is the same thing as 2. Okay. 18/4. Again, I can think of it as division. 18 divided by 4. How many times will 4 go into 18? I know that 4 times 4 is 16. And when I subtract, that leaves me with 2. And again, we don't say 4 remainder 2. We write this as a fraction. It's 4 2/4. So you could write 4 2/4, or if you know that 2 is half of 4, you could reduce it even further to say it's 4 1/2. Both of these are correct. This is just the reduced form of this. Okay? 9/3, again, 9 divided by 3. Well, how many times does 3 go into 9? I know it goes 3 times. 3 times 3 is 9, which means my answer is 3. Okay? And again, I want you to try number 11 and number 12 on your own. You can think of those as division problems. 22 divided by 5, you'll get a remainder that you can write as a fraction. And 16 divided by 8, that should come out to a nice whole number. Okay. On the next page, which is page 238, we're solving mixed number multiplication problems. It says rename any mixed numbers as fractions. Rewrite the problem using the fractions as factors. Then use a fraction multiplication algorithm to solve. Okay, that's a lot of mumbo jumbo for us to just say, hey, solve this problem. Okay, I'm going to use the MAD strategy to turn these into improper fractions. MAD strategy, multiply here, add that to your answer. 5 times 2 is 10. 10 plus 3 more is 13. And then you keep the denominator. Times, I can leave this fraction alone. I only have to do the MAD strategy for mixed numbers. And then I multiply straight across. 13 times 1 is 13. 5 times 2 is 10. So I get 13/10, which when it's improper, you need to reduce it. So if you do 13 divided by 10, it's going to go 1 time. With 3 left over, we write that as a fraction, 1 3/10. Okay? Let's do one more. 4 times 1 is 4, plus 3 more is 7. Keep the denominator. 3 times 3 is 9, plus 1 more is 10. Keep the denominator. I would get 10 and 7 is 70. 4 and 3 is 12. We're again going to reduce that. 70 divided by 12. I know that 12 is going to go into 75 times, which is going to give us 60, with 10 left over. 5 and 10/12, which you can leave it as 5 and 10/12, or you can reduce it. I know I can divide both of these by 2 because they're even, so I can get 5 and 10 divided by 2 is 5, and 12 divided by 2 is 6. So I get 5 and 5/6. Or you can leave it as 5 and 10/12. Okay? All right, I want you to try the rest of this one on your own, and then you've got your math boxes, which is page 239. As always, if you need help, don't hesitate to send me an email or a private comment. Don't forget to use those Google Meet times with Mrs. Mace, and we're here to help you if you need it. You guys have a great day.